The magic behind data science is a robust, efficient data pipeline. But what are the components of a pipeline? And what tools do we need to make one? While each data project will have different needs, there are some common structures used. We'll be breaking those down and then looking at the 3 cloud platforms, AWS, Azure, and Google, and seeing how their tools fit into these data pipelines. As the desire for data and analytics projects skyrockets, the needs for automating data pipelines has become a top priority. Most organizations have a wide variety of applications and data sources that do not work well together, so it's up to the engineers to coordinate all of that data into a cohesive collection for use in data projects. Data pipelines will all follow a similar path. It starts with the collection of data sources. This can be a variety of systems including SQL databases, NoSQL data stores, web apps, IoT sources, file shares, and more. Depending on the source and your control, you may need to get access to API keys, database credentials, or other security requirements to complete the collection step, along with gaining at least a little understanding of the data you're trying to collect. Next is the ingestion step, where data integration and ETL or ELT is performed. This could be done in bulk loads or through data streams. The method chosen will be based on the availability of data, the frequency the data needs to be refreshed, and the volume of data being transferred, and of course by the budget for the project. Now we need to store the data we've ingested. Most commonly, this will be a data lake, where we can store files that we've collected during the ingestion phase. These are raw data extracts that should reflect the source data. It's possible if data is coming from structured sources, this can be stored within a structured data store without converting to files first. Now we need to do preparation and analytics on our stored data. This can take many different forms depending on projects, but we will likely be cleaning the data, conforming and transforming it to a format and structure best suited for our needs. Then we could be aggregating the data, using it for machine learning, explorative insights, building models for data science, dimensional modeling for reporting, and any other analytical need we might have. Afterwards, the data is put back into storage, possibly using the same data lake we pulled data from, but oftentimes it's put into a data warehouse, designed to hold our now processed data. And lastly, we have our presentation layer, where we deliver the insights through dashboards, reports, notifications, emails, and services to be consumed by other applications. So what does this look like using the most popular cloud data platforms? Starting with Azure, our ingestion layer could include Event Hub, IoT Hub, and Kafka for any streaming data, along with Data Factory for scheduled loads. We'll store the data in Azure Data Lake. Processing the data could use Azure Data Explorer, Databricks, HD Insight, Azure ML, or Analysis Services, and then data warehousing can be done using Synapse. Synapse actually integrates all of these features in a single interface. And then the presentation is done through Power BI, Jupyter Notebooks, or any other application resource. In AWS, our ingestion could be done with Lambda, Kinesis, or AWS IoT. We can use S3 or Glacier as our data lake, Glue, EMR, Kinesis, and Athena for our data preparation, Redshift as our data warehouse, and QuickSight for presentation, or API gateway to be consumed by applications. And for Google Cloud, our ingestion layer might have PubSub, Data Transfer, Cloud IoT, or Cloud Functions. For our data lake, we'll use Cloud Storage. And then for preparation, Dataflow, Dataproc, Data Lab, and Data Prep will be used to process the data. BigQuery will be our data warehouse, and then presentation with Data Studio. No matter which you go with, all major platforms will have the tools available to build a complete data pipeline. Thanks for watching. If you enjoyed this video or learned something, a thumbs up would be really appreciated. Stick around for more data content by subscribing to the channel or clicking a video on screen. See you in the next one.